Okay, so attendance, number 1, present. Sylvester present. Next. 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 Charles. Charles is here. Next. 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 Shamisha. Next. 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 Akila. Next. Kendan. Absent. How do you float the column or freeze the column? Yeah. So just make this column as a constant, right? And then you can freeze, float or freeze the column. No. Okay. Okay. Yeah, this is option freeze in view tab. All right, so let's okay, so there was a small assignment, right? So you had to just apply the mass5 ms5 function. So did you do it? You did it class? Okay. Any issues with that? Right, you just have to change the function name. So instead of RMA, you just have to use like ms5, right? And then that's it. So and then you should have got a box plot for that. So if you had a box plot, you should have uploaded that to your repository. Then today we will just we'll continue, right? We'll continue our analyses. So now the last class we did normalization, right? So we did this RMA normalization to fix the variance in the data. So we had the raw data plot, and then there were some discrepancies in the median value between the samples. So to fix that, we did normalization, and then we saw that the median was then like stable, right? It was consistent across the samples. So that was the use of using the normalization technique. So once that is taken care of, then we can go ahead and do the analyses, right? You cannot do the analyses on the raw data, raw read Affy data. You cannot do the analysis on that, because you'll get like false positives, false negatives, because the variance is not right. So, but now the variance seems to be quite consistent across the sample. So now I can go ahead and do the analyses. So what I want you to do is just do the same thing. So I have the script from my last class. So you should also have the same script from what you did in the last class. So I just want you to run that again, so that we have read the samples, we have done the RMA, and you have stored the RMA into a variable called RMA. So just rerun what you ran last time, and from that point we will do our analyses, right? So for me, I will get my samples. I'll set my working directory. So my samples are on my desktop. Bioinformatics. This, I'll just put it on my desktop. I'll open a new R script. And then name that file as today's date. So Control S, save it as March 1, and then just copy things from the last script. So I'll just copy one statement at a time. Author, set my working directory, then load my library Affy, then apply a function read Affy. You don't need to redo the box plots. So just skip the box plot statements. Then I do the RMA normalization, and then finally, yeah. Just skip the box plot. Okay, so that's what you need to do. So I hope now you should have some practice on setting your working directory to your folder where you have your cell files, and then reading your cell files, and then performing the RMA normalization, and then finally getting your normalized data into a variable called RMA. That's what you need to do. Okay. Skip the box plots for this class.
Learning my hashtags like last time.
The hashtag here.
Yeah, you want to have that.
Yeah, this is just a comment. Okay, so I'm ready. Okay, so let me know when you're ready. Okay. Good so far? So, so once you run the express exprs set ESET norm, so that is when we are extracting our expression values and storing in a variable called RMA. So if you just want to look at the first few lines of this RMA variable, then this is a function called head bracket RMA. So just do head bracket RMA, and you should have this output on your console. Do you see such output on your console? Head RMA. It will just give you, so RMA is like a data frame in which you store your expression values. So head RMA will just give like first few lines of that data frame. So you see like probably like 6-7 lines have been just shown on the output. What is the error? Did you load this library? Is this correct? Read R caps A caps. It should have worked because last time you didn't have any error, right? Let's see. Okay, so I don't think you ran previous statement. Run line number 6. Okay, now you run, after this you run line number 7. That should work. Take some time. Wait.
So what would be the comment that we would put with it or
So yeah, that's enough. And you can see that head is just showing you first few lines of RFA. No. I just wanted to show you what is there in the RMA data. So you don't need to put anything on the No. Can you press escape? Yes. Escape. Okay, now up arrow. Yeah, please. Relearn it again. Error in validating argument object is selecting a method for function object is set not found. Did you run line number 4? Set to working directory. Do you have self files in that directory?
Yeah.
Okay, you can the GSEA
All right.
folder. Let's check. User desktop. Yeah, can you run the line two? Now you run line 4. Now 6 and 7.
You know what happened in our system?
The directory was not set, so you just have to rerun.
Oh,
You didn't
okay.
run the set was. But now it's out.
Now do K-RMA.
Now just do yeah.
Here it goes. Thank you.
What is your console? Yeah. Where is your answer? Let's rerun again. Okay, what is
No, that's
no, run your set WD first, second thing. Run the library, yeah. We have the files in there, right? What I do is I just That's why you want why is there a local price
Okay, so I think what we did is we just reran some of these statements, right? So first thing is you set your working directory to the folder, load your Affy metrics library. Third is read the cell files from this folder. Then you do RMA normalization with the function RMA. And finally, you extract your numbers, extract your values, and then store it into a variable called RMA. So RMA is a variable name in which we have all the normalized expression values. And head RMA, it just gives you first few lines, right, as an output. So you know that you have read things correctly. So if I do head RMA, you can see this table, right, on output, everyone. So what do you think are, so you have these column names, right? You see, so look at my output. I see you have these column names and you have these row names. So there are 1, 2, 3, 4, 5 columns, and there are 1, 2, 3, 4, 5, 6 rows. But there should be like 10,000 rows here, right? It's just this is just giving the header, first few lines of this variable RMA. So what do you think are these columns, and what do you think are these rows? Columns are samples, right? Samples. And the rows are for what? Intensities for expression for of what are these rows? What do you think these row names are? Any guess? What are these row names? What do you think these are? What are we measuring here? Intensities of in samples. What are we measuring in samples? What is? Yeah, you did normalization on what?
The CL file.
CL file, but what does that file have? Like you have the microarray chip. What are you measuring? Intensities of? What are you measuring? Huh? Of? DNA, genes. These are genes. DNA, cDNA, right? So these are gene names, gene IDs. Okay, so now you can see that these are unique. So can you define the gene names from these IDs? What is this gene? What is this gene? What is this gene? Because if you have seen, genes have a unique gene symbol, right? So it can be like HER2 or any BRCA2, right? So it has a unique gene symbol, ID or name. Is this a unique gene symbol? Can you know what gene is this with these IDs? Yeah, just by looking at these IDs, can you say which gene is this, which gene is this, which gene is this? No, right? No, right? Because these IDs are very specific to this platform. So what is this platform? What is the name of this platform? What? Affy metrics. Affy metrics. So these IDs are very specific to Affy metrics platform. Now, some of you had issues with their raw cell files because they were from a different platform. They were from, I guess, Agilent. So Agilent would have different labeling, right? Different way of naming their IDs or these IDs, right? But these are very specific to Affy metrics. So in the exam, I'll be giving you sample data, some raw data, which should be very specific, or which will be Affy metrics, right? So I don't want you to confuse in the exam and have any issues with reading these files. So everything should be Affy metrics, Affy. So this platform is Affy metrics. Now, the reason I asked you to upload 10 cell files in our last classes, because I also asked you to make a note of a platform ID. Remember? Do you remember platform ID? Now the platform ID will be used to understand what are these genes or what are these IDs for, right? So the every identifier here, ID, is a gene name, right? So we can use the platform ID file to understand which IDs are which genes. Does that make sense? Right? So there should be a file on GEO database, right? From where we got these cell files. There should be a file called platform ID. So we will be using that file. It's just an Excel file, a very simple Excel file. If you open that Excel file, you will see there is a column called IDs, Affy IDs, and in front of that there would be a column called gene ID or gene symbol, right? So you will be using that file to match which IDs are which genes or gene symbols, and then you know these genes, right? Are we clear? No. So okay. So these IDs, they match to genes. So every ID is one gene, but that information is not present here in the chips. Chips are very specific to these identifiers, platform specific identifiers. But to know which IDs are which genes, you have to go back to the GEO bank from where you downloaded these 10 cell files, and there should be a link for GPL or GEO platform ID, GPL some ID. So you click on that link, you will find an Excel file, Excel or a CSV file. So you download that file, and in that file, you would have one column as these IDs and a matching column called gene symbols. So then you can match which IDs are which genes. Yeah, I will show you that, right? That is where once you're done with the analysis, then you want to know which are interesting genes. What are these interesting IDs? What are these interesting genes? Then you have to use that platform ID, right? But once you're done with the analysis, so we haven't yet started the analysis, right? So now we will do our analysis, right? First, we will do the analysis. We will find interesting genes and interesting IDs from this data. Then we will use the platform ID, and then we will know which are those interesting IDs and interesting genes matching. Okay, so let's start the analysis. So the next thing which you do is, okay, the new thing here. Okay, so yeah.
What are interesting genes?
Interesting genes means the ones which are, okay. Okay, so interesting genes, right? Definition of interesting genes. So what are we doing here is, we are, so what we are doing here is, we are so let's see. Can you see here this section here? Yeah. Okay. So what you're doing here is interesting genes, right? So you have sample 1 and say sample 2. This is gene 1, gene 2, gene n. Gene n can be like 10,000. Now, say sample 1 is your, usually called as treatment group. And sample 2 is say control. So the setup of this experiment is I want to test a drug, right? So I have some cells, say like some human cancer cell line, right? Human cancer cells, and I want to test a drug A if it is effective against those cancer cell lines, right? So if it will kill those cancer cell lines. So what I will do is I will have two samples. Sample 1 would be the treatment cell line treated with that drug, and then I will have a control, same cell line, no treatment, right? So treatment 1 is cell line with the drug, and control is cell line without a drug. Then I will do a microarray, and I will get the table. I will have intensity values. Intensity values as we have now for treatment and for sample. Say for example, gene 1 intensity value is like 1000. Gene 2 is like 50. Gene n is like 10. And for control, same gene, intensity is like 10. Intensity is like 10 and 5, right? So this is the table, say we have from that head RMA function, right? Sample 1, sample 2, gene 1, gene 2, gene n, intensities. For analyses, what we are doing is we are just taking a fold change. So do you know what is a fold change? Huh? What is it? What is a fold change? What? Fold?
The scale.
That is true. That is what we want to do. How do you do that? What is fold change? You're scaling it down. That's true.
By finding the ratio.
Exactly, yeah. So there are two ways. First is finding a ratio, and second is subtraction. So first is you can either do division or you can do subtraction. So these are two ways you can find a fold chain. So how do I find a fold chain for gene 1? What?
The new and the old.
Can that be like both the ways or just one way? Okay, so first thing is we want to do division. So what do you want to divide here? By what?
The average of those two numbers.
No, just I want to know what is the denominator, what is the numerator? What are you dividing? What? What? That's true. Is it a treatment or control? Right? So you cannot do a control or treatment. Because I want to see what's changed in treatment. Because treatment is the one where I'm giving the drug. Right? So to do that, I'll do 1000 divided by 10. 50 divided by 10. 10 divided by 5. Does it make sense? That's the fold change. Simple. Right? So what are interesting genes? Say the interesting genes are the ones which has high fold change or low fold change. Right? So fold change value can range from say minus infinity 0 to plus infinity. Right? So that would be the range of your fold change numbers from this third column. So, so whatever is max, right? So I'll have a threshold here. and I will have a threshold here. Say my threshold is -2 and my threshold is +2. So anything above +2 is interesting. Anything above -2 is interesting. That's the interesting genes which we want to look at. That's all. So, okay, so I have sample 1, I have sample 2, I get a fold change, sample 1 divided by sample 2, and I will have the numbers for fold change vary from 0 to minus infinity, 0 to plus infinity. I have a threshold, say +2. Anything above +2 is interesting for me. Anything below -2 is interesting for me. And that is something which we'll be looking in that platform ID. Fine. Good? Good? So that is what I want to, we want to do in this example. Okay, so in this example here, I don't know what are the cell files, right? I don't know which is the treatment, which is the control, which is what, right? So we have 5 cell files, 5 files, right? So let's assume that first 2 files, 2 files are treatment, and the next 3 files are control. Yeah, let's assume that. Okay. So for all of you, the first 3 files are, first 2 files are your treatment, next 3 files or next 3 columns are control. Make sense? Okay. You're using 10 files? First 5 files treatment, next 5 files control. Just divide those columns. Okay. So assuming for me, I have just 5 files. So I'll assume that first 2 are treatment and next 3 columns are my controls. So now, let me ask you one question. So you see these values, normalized values. Are these fold changes? So what I'm asking is, so what I'm asking is, so you said like scaling down, right? Scaling down. So how do you scale down? How do you scale down numbers? Say I have 1000 number and I want to scale it down to like less than 10. Same value, I want to scale down to less than 10. What do you use to scale down numbers? Yeah, similar to mean. It starts with L, log, right? Log, right? So you know, right? You know about log scales, right? Logarithm, right? So you can have like, okay, guys. So log scale. So log can be, say, it can be base 2 or base 10, right? So you have to use log scale to scale down things. So so any value which is like say 1000 number, 10,000 number, if you apply a log scale, log base 2, then you will scale it down to like less than 10, right? So you will have all the values in the range of like say 0 to 10, right? So do you think these values are log scaled? Huh? Do you think these values are log scaled? Yeah. Okay, so to understand so what have you done? What have you done before this? What have you done to get this table? You did normalization, right? What kind of normalization did you do? RMA normalization. Let me check if our RMA does logarithmic scaling. So RMA normalization. Does it do log scaling? We just have to look into its manual. Okay, so what does it say here? What does it say? So data is normalized already because, and I can say that because the intensity values, they range like 1,000, 10,000, 20,000. That's the raw intensity values. They are never limited to like 8 or 10 or 9. You see, these values are less than 10. So the RMF function itself, it does normalization, right? Sorry, it does the log transformation, log base 2 transformation. So these are log scaled values, right? I guess if you use a different technique, say like there is another technique called quantile normalization that may not do this transformation. So just a note, once you do normalization, you have to check with the head function to see if the values have been scaled down to less than 10, right? If they are scaled down to less than 10, that means the function has applied a log transformation, and you need to apply log transformation to do the analyses. Make sense? Now, if the values does not have the log transformation, then you need to know how to do the log transformation, which essentially is a very simple statement. What you do is, there is one statement here. I'll just copy this and I'll just paste it here. So to perform log transformation, do following. That's what you do. I'll change the. So okay, so my first two columns are treatment. So I'll just main treatment. Treatment is apply RMA C. First and second columns are named as GSM cell. Second column is this cell. Okay, wait. So let me just do it, then explain you, and then you do it. And then you do mean, and then you do a transformation for log 2. Okay, so this should work. Okay, so what you have to do is, so I want to show you like, okay, so you do your head RMA, and then you see that these values, these are more than 10, right? So these are more than 10, it may be like 10,000, 20,000. So that means the log transformation has not been done by your normalization function. But you need to do normalization before you do analysis. Before you do the log, before you take the fold change, you have to take log scale, right? Fold changes on raw unnormalized data, you don't do that. So you first have to do normalization, then you do scaling by log transformation, and then you do your fold chain analysis. So now you find out that these numbers are way high, right? So they are quite high. So you need to do transformation, log transformation. So as we plan, right? So I have 5 cell files. So first 2 columns are my treatment, and next 3 columns are my control. So what I'm doing here is I'm just defining what are my treatment columns in statement 12. And in statement 13, I'm defining what are my control columns. So treatment, apply is a function. What do you think apply will do? As the name suggests, apply. What will apply do?
You skip like a whole step. Like, how are we supposed to know which ones in the data set are the treatment, which one is the control?
I just randomly divide my first 2 columns. So if I do like head RMA, right? What you did in the last line, right? So this is my output. So I'm just assuming that my first 2 columns, column 1 and column 2, are treatment, and 3, 4, and 5th column are my control. Just an assumption here, right? So how many files do you have? 5, right? So assume first 2 are your treatment and next 3 columns are your control. So what do you think apply will do? As the name suggests, apply. It's a R function. What will apply do?
It will make the groups you choose the treatment.
That is what we are doing here. But in general, what does, just I'm asking you, what is the definition of this word? What does apply mean? Add, yeah. Any better meaning of apply? It's application of anything and everything which is present after apply function, right? Apply will do application or apply everything and anything after this apply word or function, right? So apply everything in this function called apply is apply. Is it confusing? So apply means apply, right? Apply everything which follows after the word apply. Yes.
So like in the setup where it's like RMA, then bracket, why is it like a comma C? What's the comma C?
Okay, right. So let me explain that. Okay, I have to explain that. But so if I ask you in the exam, what does apply function does? You should answer that it just applies everything in that function, right? So the next thing here is RMA. So what is RMA here? What is RMA here? RMA. What is RMA here? It is the variable which has the data, right? RMA is the variable in which we have stored our data. Yes. This here, where? Here.
No, sorry, oh.
Up. Just wait for this. Yeah, no, wait for this. Just try to first write up these two statements. Okay, so RMA is the data where we have stored our data. The next is you have the square bracket. You see a square bracket here? This entire square bracket here. So in the square bracket, there is this comma here. Any wild guess why? What is the use of this comma? Did you notice there is a comma here? And why do you think there should be a comma? To separate each cell. Okay, so I'm going to give you a hint. So I have a square bracket. I have something here. I'm adding a comma before something, right? So this signifies one thing. And I have a square bracket. And there is something here. And I'm adding after this something. So this signifies other thing. So if you look at this data here, to create a length, link. No. So there is a comma. If there is a comma before, and if there's a comma after, what is the structure of this data frame? Like, what do you have in this data frame? There is and. So when you have a comma before something, what do you think it may point to? That's a good guess, but it's a column, right? So if you have a column, a comma before something, then that is where you're pointing to some columns. If you have a comma after something, that is where you point to some rows. So in this case, I have a comma before something, right? This is something, right? See, this is whatever. So I have a comma before something. So I'm pointing to the columns. And which columns?
The first 2 entries.
Exactly.
So why the levels?
Right. That's a very good question. Why is the C here? So C signifies list of elements. So in this case, we have two columns. Column one is column one name is GSM84483 cell. Column second name is this name, right? So there are more than one elements. There are more than one columns. So to list them, you have to use C. Right? So this is just a way of writing this R program, right? So they ask us to use C when you have more than one element or more than one column which you want to point. So in the exam, if I give you some column names, and if I ask you to select those columns, which statement you'll be using? Line 15 or line 16? 15. And if I ask you for rows, 16, right? So this is it's a very big difference, right? So comma before, comma after. Comma before is pointing columns, comma after is pointing rows. So now I'm pointing to first two columns, right? So do you understand the statement now, square bracket, right? So I'm just pointing to first two columns of my data frame, which is RMA. Then there are two more arguments, one and logs. So you can have this, one is optional. So I will not worry about explaining that. But then the last argument here is log. So do you know why we use log, right? Because you want to log scale it, right? So log, you want to apply log on these two columns, log scale on these two columns, right? That's all. That's the best I can explain. And do you understand the importance of applying here, apply function here, right? Because you have to apply log on every column after apply, right? So there you have one column, you have two columns, you want to apply log on this column and also this column and also this column and also this column. So any columns you want to apply log, so you use apply. If you don't use apply, then probably, I don't know, it may not work, it may complain, or it may just apply log on first column, right? We don't know, but you have to use apply if you have more than one columns, right? That's all. So that is where I'm saying that these two columns are my treatment. They are treatment, and I want you to apply log on those two treatment columns. The same thing which I'm doing on statement 13. In this case, I'm just saying that they should be controlled. Instead of treatments, I change it to control, and I also change the column names here. You see the column names have been changed to last three columns. So if you have different column names from your head function, you should change these names or it will complain. I don't know what files are you using, what cell files you are using, but when you do head, you should have this column name here. So you have to change your column name in these statements. So treatment should have first two column names, and control should have last three column names. We're good so far. Did you run these two statements? Do you have any? Yeah. Down, up. Yeah, I was just testing few things. What do you want to see?
Okay, so when we put it in the console, we just do the treatment part first.
Yes. Yeah, you do that. So I'll do it again. So I'll just do treatment. Done. I don't have any error. I'll do control. Done. I don't have any error. That's all.
So we're not supposed to get no output from.
No output. You get any output? So far, so good. Okay, so now, yeah. What's that? Anyone else? Error? So what we have done is we have just tried to group first two columns as treatment and next two columns as control, next three columns as control. And we also, so the log is an optional thing here, right? We didn't have to do apply log here because the RMA did log transformation for us. But if it's not log transformed, then now you know how to do log transformation, right? Okay, then let's wait for couple minutes, 2 minutes, and then we will do the fold change. Save your R script. Save your R script so that you can upload it after the class. What is it saying? Okay. Did you change the column names?
Yeah.
Exactly as you have in your RMA? You have head RMA?
Yes, exactly.
Exact names.
Yeah, like just sequential.
So treatment. You have 10, right?
Yes,
The first 5 treatment, next 5. Yeah, exactly. Or it will make an Good. Error in RMA C. 1, 2, 3, 4. 5, right? Sure, 5. One, two,
This is.
wait. Remove that. Remove this. First, no, yeah, before the first name. Let's run. Yeah. Basis. No.
Because, yeah, he's saying I don't want.
Right. So let's see. Treatment.
Not the treatment part work, but control is it.
Control apply RMA C. This is the stuff here. Maybe. So control is 485, 485, 47, 4846.7, and 4847.7. Yeah, you see? Space is unnecessary spaces. Space, yeah. This is better. Okay, so now I guess we have the treatment and controls. So now if I do head treatment, right? If I do head treatment, where we have stored the first two columns, log transformed. Do you see a difference here in the output? Anything different? That is true. That is true because we did log transformation. So the values scaled down more, right? That is good. There is a very second major difference. What? There is a very big difference which has occurred. What? I see IDs, that's fine, but I also see sample names here, right? But something has changed here. Yeah. Head of treatment. That's exactly what has happened. Okay, guys. So, okay, did you hear what she said? What change has happened? What? It's a cap T, yeah. head of treatment, and you should have this output, very big output. So did you hear what change has occurred here? What has happened? What is the change which we have done here? No. Yeah, we have scaled down. There are two things which has happened here. First is we did a log transformation, right? So previously you had the values like 10, 8, 9. Now it's like 1. You did a double log transformation. But there is also the second change which has happened to this data frame. She said that. So the columns and rows, they have changed now, right? Did you see that?
Yeah.
So previously you had columns as these cell names, the sample names, and rows were these IDs. Now this rows are sample names and columns are IDs. You notice this change?
Yeah.
Right? So we need to take care of this. It has transformed its rows and columns. So we need to retransform it again. Okay, so I will just I'll try to do that in a let's do that next class. So so far, any questions?
What is the head function? What is the head function?
So head function will just give you first few lines of your data frame, right? So does every one of you has this output? Yeah. Okay. So save this R script, and the assignment for next class is, before we start the next class, I want you to be ready with this output, right? So now what you can do is save the R script, close your R console, upload your R script on Git repository, and close everything. Before next class, I want you to reopen this R script in your R and run all these statements and get this output and be ready with this output. That's all. If you have any questions, you can ask me now. If not, we are done. Yeah. After manual statement, there's an arrow there. The file names are right.
Look, I was trying to find the list of I told you I had, but I was deleted it, and I thought it was in my emails. Yeah, because I ain't had no storage. I think I had deleted it for this place, but I thought I had it in my emails, and I couldn't find it there either. The, you know, from the articles, but you're on abstract.
Summarize it the way you did.
Well, first you would take a few sentences from the background. And then, you know, just write it like that, and then using from each paragraph, you know, each section, you just do a few sentences just to summarize it, just that way, and then, you know. If you need help, just hit me up. Mhm.
And then
But these people don't, I think so they don't make a reservation. I think so she don't make a reservation. Maybe. You know, we won't get it.
she don't make now what they're saying is most likely they don't book flights for them to New Jersey.
How they will use take book like
The man and that old man said, does it again? The man over there, March 22, 21. That's the truth. Just the random way it can't be for house. Now we're going to have like say there and I did
they yeah, but before how I'm gonna have
Patricia never got it. Now go ahead with the hammer that I need the hammer step one man.
so we think will happen now, but it's no go refund.
You know,
I think the only thing they feel it on now.
well, I need to talk to them. I never talk to them. I don't want to do that. I don't want to. I need to talk to Patricia and to both of them before I do everything. Before I say anything. That's just it for me.
One person is fine. I never get since this. The government is not ever seen it.
You didn't need the Kadate.
I want to go this from there. I want to go as an alpha. I need to go.
There's someone waiting now.
Alpha, mirror or the.
It's like
Get one thing, I wait there for the now.
So you don't do that.
You know the one yeah, man.
You don't do that.
This is.
You must do that. You must do cover the account.
Okay, you must pay first.
We don't do that till December. We don't do it for the year. We don't do that.
So I just pay before I order again.
Something like that.
Apply RMA.
Well, yeah, first, I want to decide if order without.
Yeah, I want to find
Yeah, I won't go ask them, say, what if I pay? I know if I did this year. This paper.
I'll go to report.
Whether they go, I won't go that register, please go ask. Just to be sure. I don't want to make my money hang anywhere.
So what is we have RMA?
I think I go register office. From there, I'll go to spam office. I'll come back and I will come my phone and go out.
So you see the file names are different.
Yeah, man. Wait me and they talk. Yeah, but I don't know it.
You don't know about the work. You don't know it.
No, you know about the crops, not the germinate. How on that nature? Not just related to talk. I just want to say making think about them from nothing. Make me think about something.
I will take that.
And they propose make I propose which I get to it. Yeah.
Now maybe I will get like maybe one more try. And not talk.
I want to do one more try.
No, not be like 45. I can't time it. At least.
How do you say for me to run like that? Now 3 weeks. Now 3 weeks. If I say now I won't start now, then now for run I'm maybe I for not tell the side you do 3 weeks. I go through.
Now I that treatment.
She said I don't
You see the names have you still have an extension here. So that was
you know when I play that, they think about that. I did not talk about it. Don't wait like this everybody. I don't think about this since. Just waiting here, they don't make the difference.
You still need, I say you still have it to you. But I don't
I know you're not here. I know you're not here.
That's I think
Right.
I got your email. I saw your email.
yes, sir.
Did you got a chance to look into?
Okay, so I want to close this and open our next place.
Yep. So then I think the running from terminal was working. You just have to figure out the FASTA file,
Yeah.
DFA file, right?
Yes, sir. Well, I think I tried to get something. I want to show it I want to try and run one now and write it from the.
Yeah, let's do that.
160. Let's see.